All right, so let's see what we got.
Also, James, Bailey stole my kidnapped babies.
Y'all are so weird.
Bailey stole the kidnapped babies.
Kidnapped babies. All right, I don't want to know. I don't want to know. Okie doke, people. So
Double kidnapping, we got this.
let's see. So what was the which vehicle? First off, which manufacturers make EVs? What have we got? James, what have you got?
GMC, Ford, Rivian, Audi, Porsche, Jaguar, Mercedes-Benz, Volvo, BMW, Cadillac, Mazda, Genesis, Tesla, Nissan, Subaru, Polestar, Volkswagen, Mini Coopers, and Kia.
Very good. Does anybody have anything different?
There's probably more.
So there's a lot. There didn't used to be. Like if you were to do this 5 years ago, you wouldn't have anywhere near that many. Yeah, he said Rivian. Okay. So has the federal government offered any tax breaks or financial incentives for purchasing over the last 10 years? What do we find?
Yeah.
Yeah.
Not in the state of Florida.
Okay. And the state?
No.
Specifically?
Incentives.
What now?
What?
I think it offered incentives from what I Googled.
Offered incentives? Okay. What'd you find, James?
I found that if your vehicle weighs less than 14,000 pounds, you can get up to $7,500 taken off the price of your vehicle. And if it weighs more than 14,000 pounds, you can get up to $40,000 off.
Yeah. Is that the new one that's going into effect this year? Yeah, there's a brand new one going in 2023. And it was a federal one. It was part of the what's the act? Do you have it? I don't know if you have it. It's the one about recovery from the Economic Recovery Act or whatever, something like that. And they put different guidelines and stuff on electric vehicles, and you can get a $7,500 tax credit, which is the same as getting that taken right off the top of your vehicle. And they had, because of the specifications, like James was saying, due to weight, the manufacturers actually made some alterations. Ford in particular and Tesla altered the Mach-E and the Y so that they would qualify. So smart, because now that means more people will buy them because, ooh, if I buy this car, it's less, right? So what make and model is the best selling? What do we find? James, what'd your team find?
Tesla Model Y.
Model Y? Did anybody find anything other than Model Y? Model Y seems to be the answer. And what was the MSRP or manufacturer suggested retail price? What'd you get, Drew?
So we found 750 grand.
Whoa,
What?
that can't be right. 750.
Sorry,
Wait.
price?
Yes.
Oh, I was like, how many of these?
Oh.
How many of these? No, 39,000.
That sounds more like it.
What?
How
What-
many have been sold in 700?
Okay, 750,000 sold at 39,000. What'd you find, James?
54,000 on the
54,000
lowest trim.
on the lowest trim.
Website, it was 54,990.
Yeah, that actually sounds closer. 54,990. Yep.
You're going to Iconic.
56. Yeah.
Yeah, if you went for a slightly upgraded Model Y, it would be 58,990.
Yeah, I figured 50-ish. So that's probably about right. He's like, something's wrong with this. And then how many were sold? What did you guys get?
That was not by
750,000.
Okay, so Drew had that too. Did you get that, Lily, somewhere in there?
Sure.
No, it's 58 grand.
Okay, excellent. Yep, that's all right. That's all right. Okay, so what are the batteries for the Y made out of?
lithium ion.
Lithium ion. So how do we get lithium? And what, okay, what else were you gonna say? Something else too? Or lithium and
Some of the batteries are actually liquid cooled.
liquid,
Also got nickel, copper, and aluminum.
nickel, copper, and aluminum. Okay. So we have to mine these things. Does anybody get so far as to find out like where they're mined? And
Normally China.
China, India?
That's what I thought.
Ah,
Well, certain parts are mined in China. I believe the graphite.
It's also in India and Mexico.
okay, cool. So remember that mining has an environmental impact, right? So especially if these cars are being advertised as a greener alternative, keep that in mind, right? That's what all of this is looking at what's advertised as green and is it really green, right? All right, so if your EV's battery manufacturing produces carbon emissions, how do those compare to those produced by driving gas-powered vehicles? What did anybody find for this one?
For us, we found.
Wait a minute, James put his hand up.
Manufacturing the battery produces about 11,250 kilograms of CO2 per battery.
Per battery.
And
I'm
I'm
driving the Toyota 2020 Camry.
Okay, that was your comparable car.
For its
Lifetime.
expected lifetime.
Mm-hmm.
Produces about 83,042 kilograms of CO2.
So which was more?
Gas.
Gas was more. Good.
Yeah.
Okay. What'd you find?
For us, well, I think the most high performance car I think of is called.
SUV?
Yeah, so
Yeah.
we show us a Trackhawk. It has a Hellcat engine, so
That's a Durango, right?
we had 16 metric.
Or is it a
tons.
Jeep?
The Tesla of CO2. The Trackhawk was 80 metric tons, so.
Okay. What'd y'all find? Anything different? Anybody find anything different? Lily, Chloe, you guys found similar numbers? Okay. So how long do the batteries in the Y last? What'd we find?
what was the answer to that? Again, I was not what part of.
Chloe, what'd you guys find?
Their lifetime is around like 15 years.
15 years? How about you, Drew?
Look at the paperwork.
Yeah.
Oh,
No?
total, well, I said 500 miles per,
No, I'm asking how long do the batteries last?
that's what I thought.
Oh, 500 miles per charge.
Well, depending.
How many well, then you'd have to know how many charges. I'm asking how long that battery lasts before it needs to be recharged and can't do it anymore, like it's dead. What'd you find?
We got 10 to 20 years, I believe, and 100,000 to 200,000 miles.
Okay, 100,000 to 200,000 miles, 10 to 20 years. Okay. 50,000 miles? I would hope it's higher than 50,000, but still. 200,000 miles? Okay, yeah. Does anybody know the mileage on the vehicle your parents drive as their primary vehicle? Like what one has does the most driving for you? Anybody have a clue?
Over one, less than a million.
Over one, less than a million?
Our van is at almost 300,000.
Your van is at almost what kind of van is it? Toyota, 300,000 miles. Ours is at 141. How about you? You know? Hey, Yusuf's talking. Wait a minute. What'd you say?
5,000.
Would you just look at it today?
Ow.
Okay. Hey, that was very, very accurate. All right. So yeah, and most like the best warranties you can get on gas powered vehicles are usually like 10-year, 100,000 mile warranties. So it is expected that your gas powered drivetrain and engine are going to last at least that long. All right. So what happens when you're at the end of life for your Tesla Model Y battery? What'd you get, Alex?
According to Tesla, they are 100% recycled.
Okay. All
Now,
right.
We don't know if that's true or not.
What'd you find, James? Same thing? What'd you find?
Well, so some of them are recycled in recent days.
Mhm.
A lot of them are trash piles and are actively destroying the environment.
That's a concern. Same thing actually goes for the blades on the windmills,
Same thing. Yeah.
the wind turbine windmills. Yeah, those blades in particular are a landfill concern. So there's all kinds of stuff like this that comes along. Yeah. So how much does it cost to replace the battery? What's a Y battery cost, Chloe?
85 to 125, which didn't really seem right.
Yeah, that can't be right. Would you get
But
45 to 250.
4,500 or dollars? Oh, dollars. What'd you find, Yusuf? 15,000. What'd you find?
We got
From-
4,000 to $20,000.
So wait a minute, Yusuf, what was y'all's source? Do you remember?
I will show you. It was how much money does
Was
a
this Tesla?
Tesla Model Y buy?
No, but where'd you find the information?
Wait, no, I can't remember. That was part of the Taliban. That wasn't. Where did you find that?
Okay, hang on. Wait a minute. Chloe's looking up. Where did
Right
you?
here. It comes from.
Shh.
It says from www.way.com.
Way?
Way.com.
I don't know what that is.
Let's see here. What is
This
there?
is from straight
It
from
said
Tesla.
Straight from Tesla. And what did Tesla say the cost was?
No,
4,000 to
no.
4,000 to
Parker
That's
got it from Google, and we don't know when the third side is.
4 to 20 is a big spread.
Battery replacement cost comes to around $15,000
Yes.
approximately.
I've heard between 10 and 15. So it kind of depends. So based on what you found then, what percentage of your vehicle's cost is the battery? James?
7 to 36.
7 to 36, Drew?
38.5.
38.5.
Oh, 38.46.
That's 5.
Come on.
That counts. Does anybody know what it costs to replace do most of you parents have minivans or something similar, SUV size cars? Yeah. Anybody know what those engines cost
A lot.
Same thing.
to replace the engine? Anybody? Usually 4 to 6 grand. It's a good chunk of your vehicle is the engine. It can be more. I know this because we had Jiffy Lube once install an O-ring incorrectly after changing the oil in my husband's Sorrento, and the engine locked and died and got to be completely and fully replaced on Jiffy Lube's insurance. And then I had a fluke with my car and it got replaced from Kia because it was under the warranty. But yeah, they're somewhere 4, 6, it depends. Sometimes they're less, depends on what you're getting. All right, so now we have our gas powered vehicles. So what gas powered vehicle did you chose? The Trackhawk. You chose the Camry. What Camry specifically? Camry, wait a minute, hush. 2020, what was the trim level?
Base.
Base. Okay. Lily, what did you guys choose?
We chose I don't think it was Honda Escape 20, yeah. that was-
Honda Escape 2023. And Chloe, what'd you guys pick?
Lexus RX, 2020.
Lexus. Okay, great. All right. So what was the average cost today for gas? Who found it? Okay, what did we find, Piper?
$3.1.
$3.10. What'd you find? 3.15, whatever. Yeah. What'd you find? 3.14. Okay, so yeah, so depending on how you're using a number, a 3.1 you could definitely round to in certain situations, but people get ridiculous about gas prices, and I've never understood it. But folks will, no joke, drive across town for gas that's a cent cheaper. And when you're filling your tank, it's a 20-gallon tank or something, you're talking about 20 cents. To me, it's not worth driving across town, but my mother-in-law and other people I know will they will do that. They will drive just to go to the cheapest gas. So if you've got gas stations on opposing corners on an interstate, for example, yeah, you pick the one that's cheaper, but sometimes it doesn't matter so much.
That's what happened. So I was today. That's what happened. I was coming right here,
Mhm.
and our gas got to 2 miles. I told my dad to go to a one that's like 2 miles from here, and he's like, "No, that's like 10 cents higher than the one."
Now,
that's-
10 cents is a lot. That'll add up. Because that, $2 or whatever adds up over time, but 20 cents is,
Zero.
oh, on your how many miles left? Is your dad one of these folks that drives it down to the fumes? Some people will do that. Yep. All right. So if the gas price stayed the same, what would your gas powered vehicle's fueling cost be for the number of miles equal to the battery life of your EV? What did we find? Who found something good? Lily, what did you guys find for number 10? Yeah.
About 30.
30,000 or 30 for, how much would you spend on gas in the same amount of time, roughly?
They got a measurement for that.
Hang on. All right, they're looking. What'd you find?
Oh, okay. You mean the cost?
Yeah,
Yes.
Yeah, it'd be close to 150,000.
$150,000 in gas. Okay, how about you, Drew?
So when we factor in how much money it costs, we also factor in how many fossil fuels you have to burn
Yeah,
for the charging compared to how many fossil fuels you put inside the car.
we're getting at that one, but yeah.
About the same for almost everything.
Okay, what'd you find, James, for how much does it cost to put gas in your car?
42,000 to 84.
42.
Sorry. 14,000 to 30,000.
Okay,
Depending on
We
whether
also did a-
the Tesla died at 100,000 or 200,000.
right, that's a big gap. Okay, so what you're trying to figure out here is how many miles per gallon does your vehicle get? Like, for example, we'll just say mine gets 20 because it gets 19 in town, 22 highway. You guys probably saw that, right? When you looked up your vehicles, it would say something like so-and-so many around town, so-and-so many on the highway. And then there's like an average of the two. And that's because typically you get better mileage on the highway because you're not stopping and going, right? The newest of cars, like within the last probably 2 or 3 years, turn off when you stop. Have you seen this?
Yes.
Yep.
Right? I've rented them and it makes me anxious because you get to a stoplight and it just turns off. That usually is not too difficult of a thing to deal with unless it's 90 some odd degrees outside and your air conditioning's running. because it doesn't stay cold when the engine's off. So that's a thing. All right, so then if you compared the price of gas today, if you know your Tesla battery is gonna last 20 years and it goes for about so and so many miles, then you can take that same mileage and multiply it by the cost of gas and figure out how much it costs you to drive your gas powered car. So what is the carbon emission for your gas powered car for the same number of miles that your Tesla battery is gonna last? What'd you find, Alex, or no, James? James has a paper.
42,319 to 84,638 kilograms.
All right, in the 40-ish thousands. Okay,
And that's on the low end of the battery.
that's on the low end. Okay, how about Lily? What'd you guys get for number 11?
Remember
Mm-hmm.
the carbon emissions?
Yeah. Mm-hmm.
I got about 4.6.
Okay. All right. What'd you get, Chloe?
Around 50,000.
50,000. All right. And what'd you get?
Or
What'd you get, Drew?
you mentioned everything.
It was exactly the same. Wait a minute. What was the carbon emission for the Trackhawk?
I didn't write that down.
Oh, that's what you need to know.
Exactly the same for both the Tesla Model Y and the truck.
That's interesting. Okay. What are the most common sources of electric power in the US? What did we find as number one across the US? What'd you get, Piper?
Also fuels.
Fossil fuels. Anyone in particular pop out? Yusuf?
Natural gas.
Natural gas
With 38% according to the EIA.
is natural gas.
Yes.
Yeah. Okay. Sounds about right.
And
What's the main power source in the state of Georgia?
Also no.
Drew? Fossil fuels specifically?
Again, gas.
Natural gas, right? Correct.
Burning.
All right. So what method of electric power produces, or what methods produce pollution? You guys already said it. Fossil
Fossil
fuels.
And nuclear produces like a few grams per kilowatt.
Yeah, nuclear does definitely produce some pollution, far less than and not specifically the carbon emission type that we're concerned. The nuclear stuff, you've got to deal with what do you do with the waste products? That's always a thing.
More efficient as we go.
It does. Yes.
But I was just like, when you see the images of those, like the big towers with like the gas coming out of it, that's water.
Yes, that's good. So
It
Drew,
looks bad, but it's water.
Alex, turn around. So Drew just pointed out, this is true. When you see the nuclear power plant towers, right? And then there's this vapor coming out, that is water vapor that's used for the cooling at the core. But it looks like, oh my gosh, are they putting smoke or whatever in the air? But they're not. It's not smoke. So what's the average kilowatt hour consumption for charging your EV's battery? What'd you get, James?
11 kilowatts an hour.
11 kilowatts an hour,
11.74.
11.81. What'd you get, Drew? 74. Wow. I think y'all missed that one. What'd you get, Chloe?
Wait, down, like,
14.
wait,
That's not what matters.
375? No, wait,
That's probably the miles.
sorry.
Yeah.
I can't read it.
That's fine.
Yeah, then 20.
Okay, what did you guys find is the average number of miles or miles per day that a charge is going to accommodate for the Y?
Yeah, it's right here. Next page. Tesla Model Y has a 74 kilowatt hour battery, which is equivalent to about.
That's the battery.
How much does it take?
That's not the same to charge it. That's what the battery produces, not what it takes in.
And we found it to be an 81 kilowatt hour.
Okay,
Straight up.
so back to the second half of the question. What's the average number of miles per day or however miles that a charge is going to take you, James?
287.
287, about 300-ish,
Use every last drop.
250. Yeah. Okay. Does anybody know roughly how many miles your family drives a week? Anybody ever looked at that? Do you know?
70, 50.
Okay. All right.
How many again?
It depends on whether or not we're driving to calm. Sure, we have to look at it. Probably, I was gonna say two to 300, I think is probably close for us, 200.
It'd be like 150, because my mom has to drive, like, they have to drive me to Liverpool and stuff.
It's probably more than that then.
Yeah.
Like I do, like I said,
Week and then back and forth.
yeah. A good way to get an idea of how much you're driving a week, there's two ways you can do it. And it doesn't even necessarily have to give you a week, but two ways to figure it out is when you hop in the car today, check the mileage and write it down. And when you come to hop out of the car next week, check the mileage and write it down and you'll get an idea. And it's interesting because most of you guys are either driving or about to drive, and that's good to know. Secondly, another thing you can do is wait until your parents get their next fill up at the gas station. So when the tank is full, most cars have a little button you can press and it will put a zero counter. It's not the odometer, but it's like a secondary odometer, and it'll put a zero counter in. And if you manage to go more than a whole week without filling up again, you can just look at that number and see what it is. Or you can wait until you get to the very, very bottom and have to fill up again, which it seems that Yusuf's dad does, and figure out how many days it took you. And see, is it a week? Is it more? It depends on us. Sometimes it's a week, sometimes it's a little less, sometimes it's a little more. But my car will go about 300 on the tank. All right, so we did that one. At this number of miles, what would the carbon emission produced by your gas powered vehicle be, Drew?
0.1 metric tons per hour.
0.1 metric tons per hour. How about if it drove the same number of miles that a charge will give you? That's what we're looking. What'd you get, James?
Same thing.
I didn't give you the right one for that. I
Yeah,
missed the rest of
It was the same,
That's okay.
same thing.
it was another one of the lifetime answers.
Yeah.
Did anybody get one? So nobody got a good solid one for this? That's all right.
It's the same.
Let me-
10.097.
Yeah.
10.0, wait a minute, 10.09
That's that. Okay, this is supposed to be about your side.
kilowatts. Well, it shouldn't be a per hour. That shouldn't be,
Well, you could just straight like, I don't know what you're asking for.
15.
Yeah.
Yeah, what was it? Say it again.
10.0. Yeah, okay, yeah, 10.0975.
10.1 kilowatts is the average kilowatt per hour consumption for charging your battery. So then, or not that one, but whatever it was you said before, I don't remember. So how many miles would it, at this number of miles, what would the carbon emission be? So what was your batteries for charging or miles per day? Because the next question, right? Yeah. So this next question, 16. So how do the carbon emissions for charging your vehicle for this number of miles compared to those produced by driving your GP? You said they were a wash, Drew? You said it was a wash, basically, but for number 16, they were the same? Is that what you're saying?
Yeah, everything is, almost every single thing is, it's 24 gallons, 24 gallons.
Okay, then what did you guys find?
I think the truck was more efficient.
More, really? I'm gonna have to look that up. All right, what did you guys find, Chloe, for 16? Not sure? Looking at it. What'd you get, James? Oh, Alex, 16?
We did the wrong math.
Oh, okay, then never mind, we can look at it later, another day.
No, but it should still be the same. Theoretically.
All right, so
It was about
about the same?
half.
Okay, so now that you've got all these facts, these figures, these numbers, done this research, so who has thoughts on this? What are your thoughts on purchasing, the cost to purchase and operate? Drew, what do you think?
I think that they are better for the environment, but the problem is that it's okay if like one and a bunch of people do it, but there really isn't the infrastructure for everyone to do it.
That's a very good point, Shh, Alex. Mm-hmm.
It would, the infrastructure just isn't there. There aren't.
Okay, so Drew has a point about infrastructure. Okay, that's a very, very good point. How often, now you're seeing more and more electric car parking spaces, right? We see those, they're pretty common now. Certain places always seem to have one, but I still see more gas stations. How about you guys?
Yeah.
And you get in and out of a gas station in a matter of 5-10 minutes, but you may need to stay at a charging station for closer to 20 or more. So,
There's less of them in circulation as well.
right. Okay. So one of Drew's points is that it would be great for everybody to have a Tesla, but the infrastructure to run and charge them doesn't exist properly. Okay. Lily, what was your team's kind of overall thought on purchasing and operating?
Even against that.
Oh, you didn't get to that far? Okay. Do you have an opinion based on kind of just chit chat? Yeah.
I mean, Teslas are fine.
Mm-hmm.
Like, they definitely do help, but
Yeah.
there's, like you said, there's just not enough.
There's not enough infrastructure.
Especially since everybody's so used to the other ones and there's more like things that
Mm-hmm.
they're cheaper to do, designs. to-
Yeah, this is true. Yeah. Generally
There's
speaking.
only, like 2 or 3
Yeah.
designs of like Teslas, so
Mhm.
more people would not. particularly like.
Right, that's true. There's less variety to pick
Yeah.
from. Alex, James, you guys have yours. What were your thoughts, Alex?
Hang
Hang on, I asked for Alex. What now?
Camrys are cheaper.
Camrys are cheaper. Okay, there you go.
That's about all we.
And
I used Toyota Camry.
Piper, Chloe, what'd you guys come up with? Caitlin?
not realistically what's the average human?
That's a very good point. They're not realistic. Yeah, Tesla is definitely. Now, this is what's interesting. That's a very good, stop talking. That's a very good point. This is why, this is very interesting. So your number one selling electric vehicle was the Tesla Model Y, right? Everybody agreed? Everybody found that same data. Okay. But as Chloe's pointing out, they're not realistically affordable to most people. So there are plenty of electric vehicles out there. We just pointed out a ton of them, right? But they're not affordable to most people. So who's buying the Teslas? Piper.
The upper
The upper income bracket is buying the Tesla because they can afford the Tesla. Okay, yeah. But why aren't those other less expensive ones selling more, do you think? What do you think?
not as good as cost.
Because they're not as good, not like what do you mean by good?
Like some have as good miles per hour.
Like the cost to operate is still more? What do you think?
There's charging station.
There's that infrastructure discussion we had. What do you think?
One part's gonna be convenience, like Yusuf said, one part's gonna be, they don't get as much mileage out of the charge as gas gives. Another is probably still a little more expensive, and people might not know about it, is another one.
People may not realize that where the efficiency lies. Yeah. So if you look at some of these less expensive EVs, like less expensive than Teslas at least, they can definitely be energy efficient for sure. And some of them are a little more cost affordable here. But here's the other thing: cost effective, affordable. If you put a Tesla next to a Prius on a 1/4-mile track, what's going to happen?
Smoked.
Which one's going to get smoked?
Yes.
Yeah. Okay. So this is another reason people are buying Teslas. It has, for a lot of people, it's going to have less to do. Liam Parker, it's going to have less to do with the energy efficiency, less to do with the fossil fuels, and more to do with the performance.
0 to 60 in 4.8 seconds.
Yeah. Is that the Plaid or is that the Y? What's the Y? What's the Plaid get? Does anybody know? Yeah. It's ridiculous. It's like being launched. Drew?
Well, the new Tesla Roadster, if you buy the SpaceX package, which puts rocket booster on the back, it's 1.1 seconds.
Yeah. That's insane. But it's not, they're not road. That part of it is not road legal, I don't think. So anyway, these are things to consider. I'll tell you this, they're at the old, the drag strip in Brazelton that has since closed. We went for Cole's 15th or 16th birthday. I don't remember, but we went. And basically the way it was set up is you could come in and take any vehicle you own and drag it. People were running minivans. I'm not kidding. But I mean, people were dragging all kinds of stuff, and the little time flashes up at the end of the 1/4 mile. Bing, this is how fast you went, right? The car that smoked all the other cars was a Tesla by far.
150.
They have incredible torque because it's instant. They don't have to wind up so much, you know what I mean? So there's a lot of that. A lot of Tesla driving has to do with the performance of the car and the fact that it's beautiful, it's streamlined, it's minimalist. Like Elon Musk has really marketed it for a whole
Ugly though.
yeah, it's a whole level of luxury that he's aiming at.
You bring a computer in the center with the RTX 30.
Yeah, there's all kinds of stuff with them now. Okay, so would your opinion about whether or not you drove an electric vehicle change if you lived elsewhere, Piper?
Yeah, maybe if I had to live somewhere with like better benefits for.
Okay. Better tax incentives or things like that. That might make you want to buy one, Drew.
Well, yeah, because it also depends on where you live is where you get your energy from. So here
Mhm.
it's mostly hydroelectric. So
In this area,
it is
correct.
around California.
Right. Do you see Teslas on the road here every day?
Yeah.
Yeah. So the Teslas that are on the road here that are in any of these kind of North Georgia counties are predominantly getting charged by power coming from hydroelectric, which is relatively clean, as you said. So those guys really are making some degree of an impact. We don't know how big or small because that is left to be argued, which will come up in 2 weeks. But yeah, they are making some level of an impact. If you lived somewhere where the main power source was burning coal, then what kind of an impact are you making there if you buy a Tesla? Yeah.
Exactly the same. Well, exactly the same compared to a track hopper.
Okay, yeah, but I'm saying living where there's living where there's hydroelectric power versus burning fossil
It's
fuels.
worse.
Okay, what were you gonna say?
I would not do that because.
Yeah, that's the point. So if you're living somewhere where you have to charge your Tesla by electricity that comes from burning coal, you're undoing a little bit of what you're doing by driving the Tesla as far as emissions go, right? Because maybe you're not putting gasoline in a car that's producing emissions, but you're charging it with power that's coming from burning coal, which is producing emissions. So you're producing emissions on one end or the other, either in your gas powered vehicle or your electric vehicle.
I was gonna say, so it isn't worse compared to the average car, but it just isn't anything.
That's right. It levels out. Okay, so if you all will leave a copy of the lab up there on in the folder for me, I'm gonna make copies for you all so everybody can take them home and you can compare and look at them, whatever, and then get yourselves ready for a lesson. I want to see if I can get this to run. Oh, because you're living up you. Does she does. She quilts you writing every week. Monster. This is why he's a brat. My vote was their move.
Move.
Let her in, Alex.
You know, this is my thing.
Alex, let her in. Save your sibling fights for home. Y'all are crazy. Your poor mother. Why is it doing that to me? I need to fix that.
Now. It is.
Post there.
Tail's too far away.
Okay, weirdness.
You guys do not need.
I need to work that meeting right now. Go about to go, and that's the last, so. There's a whole.
This
Where they went. Right. All right, Miss Piper. This was you, yes?
Yeah.
Yes. All right. I need everybody's full attention for a minute because I want you to understand what's about to happen. Don't get confused about it later. Who am I missing?
Jack.
Jack. Milo. I know Jack. I mean, who's here? Milo. Okay. Oh, sorry, Milo. I thought Cole grabbed those this morning. He did not, apparently. Okay. Sky, I know that too. I mean, like who's like Drew's not around. Okay. I am going to hand you your handout lab sheet for lab 2627. That's not next week. That's the week after and after. We're going to be doing the second half of our climate change documentary, Compare and Contrast. All right. First, we're going to watch the direct sequel to An Inconvenient Truth, which is called An Inconvenient Sequel, Truth to Power. We're going to watch that. And then we are also going to watch a 2-video series called Climate Hustle. And they are different in many ways, certainly different from the perspective from which they're presented. So what I'm going to do is I'm giving this to you now. And Jack and Sky can grab them next week. There are going to be questions on here that you can answer before watching. Okay, it's pretty clear which ones you're gonna have to do before watching. Start working on it. Because these are gonna be due, like, as soon as the lab is done and we're moving into another quarter. So you're gonna wanna have it done. You're not gonna wanna be sitting here the last day trying to fill out stuff that you could have filled out beforehand. Stuff like, who's this person? What have they done before? Right? Okay, so I'm gonna hand these to you. Put them in your binder. I would probably stick them at the very end. That seems like a logical spot. So you've got questions for the first film, questions for the second film series, as well as 2 little pages in here for notes. Now I'm gonna show you your little pages for notes. You have 2 pages that look like this. They're back and front. That is probably not gonna be enough if you are taking very, very good notes. When I watch these movies, I sat down with a notebook and I wrote the entire time. I wrote everything that I could hear, listen to. It's a good practice for note taking when you get to college. You're gonna wanna take tons of notes, okay? Scribble, scrabble, make your own shorthand, whatever works, because you're gonna come back to this when the movie's over and it's gonna ask you a specific question and you're not gonna be able to remember it if you don't write everything down, especially if it sticks out as significant, right? Oh, that is a brownie point. What? The date had an extra 0 in it and Milo caught it. I don't know how that happened. That's a good one, Milo.
Yeah.
All right, that's one more for you guys. You're at 13. 25. Okay, Drew. Shh, shh, shh. All right, so let's do this. We're gonna start unit 7 now. This is our unit on resources, all right? And this is a shorter one. There's really only like this class, next class, one more class, but then the lab, this lab, 26, 27 is gonna take one normal one normal lab time on lesson 26, and then it's gonna take all of lesson 27, all of your lab and all of your class time is gonna be watching the video and writing notes. All right, so let's do it. What are our natural resources? Okay, so where do our natural resources come from? All right, Alex, it's such a hard one.
Nature.
Nature, yep, that'll work. I'll go with nature. I wanted earth, but I'll go with nature. All right, so then what kind of resources then are replaced by nature in a short time? All right, Liam.
Renewable.
These are what we call renewable, all right? And how about the ones that, what is it called when you replace resources at a steady rate, same rate at which they're used? Chloe? Sustainable or sustainability. Okay, so this is, or sustainable yield. So this is what it is when you are using resources at the same rate at which they replenish themselves. So trees are a great example of this, right? Responsible forestry for timber industry, they will, take out the timber they need, but they will plant new trees and they'll try to do it at such a rate that they're doing this chunk of forest, and in so many years, these other trees have come around to maturity. Trees take a long time to get to the level of maturity at which they're being cut down, right? So it takes some work, but they get there. So sunlight doesn't need replacing, right? It's got 5 billion years to go. So this is why we deal, that's what we're guessing, about 5 billion years.
And by the time sunlight's not here, planet Earth won't be.
Yep, it won't matter. Nothing will matter.
We'll destroy the Earth.
Yep, it won't matter the slightest bit. So these are our options for some of our renewable resources. So hydropower, wind, solar, geothermal, and biomass. All right, so we're going to talk about all of these today. Now, what are these resources that exist in fixed amounts in various places on Earth? Non-renewable. Okay, now when you think about it, technically, they're renewable, but we're talking how long? How long is it going to take, Piper?
Like millions of dollars.
Millions and billions of years. Way too long for us to consider replenishing it. You can't plant more oil fields like you can trees, for example. That's not a thing, right? So these are considered in fixed amounts. And these are things like oil, coal, nuclear, natural gas. Now, if we're thinking about nuclear as non-renewable, how does nuclear compare to these other ones as far as like how much of the fixed amounts available? Yes.
There's a lot more.
There's a lot more. Why is there more? Because you know what? That's part of it. Mm-hmm. Right. Okay, Drew.
Not only is there more of it, but for a smaller amount, you can produce way more.
That's the point. That's a big point. Okay, so an itty bitty amount of the nuclear material or the material required to make nuclear power can produce tons of power compared to that same amount of fossil fuel. It's just, it only requires a small amount of that finite resource. Uh-huh.
The nuclear weapons that were used in World War II, use maybe a pound each.
Mm-hmm. Good point. Yeah, these nuclear reactors and stuff we're talking about, I mean, it's the amount of material that's in them is smaller than the gas tank for your car, you know. This is something that will make me disown every person in the room. What's this word here, right here?
Nuclear.
Nuclear. It's nuclear because it deals with what's the?
Nu-
A nucleus. If you say nuclear, I'm gonna start shooting you with the Nerf darts. So that was your warning because you said it twice. I listened. So you didn't even realize it. This makes me insane. This was like, I will never forget it because this is one of the things that George Bush used to do that made me nuts. There's no way he didn't have people tell him how to pronounce it. He just insisted on doing it wrong. I'm like, stop it. And it was during the whole nuclear weapons stuff. So we heard the word constantly. And I wanted to step through my TV screen and strangle the president and go, my goodness, can you at least model correct pronunciation? But anyway, nuclear. It's never a nuclear. Nuclear is not a thing, but it's funny because we do say nuke, like I'm going to nuke this, I'm going to nuke that. So people want to go to nuclear, but that's not it. All right. So here's the thing with our resources though. There's distribution and consumption. So Bailey, what am I wanting here for this first one? Resources are not evenly distributed. And they're also not evenly what? Bailey again. They're not evenly used or consumed. That's what I'm looking for. Yeah. Okay. So there are some countries that are super rich in a particular resource. And then there are other countries that use a lot of a particular resource that they don't have. So it's not even across the board. Drew. Saudi Arabia has what? Oil. There's a lot of oil in the Middle East in general. And Russia. Where do we get oil in the US? Where are big places for oil?
Texas and parts of Alaska are
Mhm.
big.
Texas and Alaska are big ones. Yeah. No. If you go look, if you want to do something interesting, if you're a nerd like me, some of you are and know it. When you have a minute, go to Google Earth and zoom in on Texas and look towards the southwest corner of Texas, and you will see oil fields with all the little, the big oil derricks, the little machines that go up and down, the pumps, and they're in perfect little grid. They're lined up. It looks like engineering paper from above. And as you zoom in, you see what they are, but they're perfectly spread out and there's miles and miles and miles of them. So it's kind of interesting to see. Now, Texas is not using all that oil. No way. They're selling that oil to other places, right? Other states, other countries. Where else in the US do we get oil besides Alaska and Texas, Drew? Well, we get ours from there, yes, but I'm talking about in the US. Where do we get it? You said? There's some places like that. How about offshore? Do we do offshore? Yeah, offshore. So offshore drilling, this is when they build these giant big oil platforms. You've seen them, right? Yeah, they're big oil rigs out at sea, and those guys go and spend like 3 to 6 months on the rig, and that's their shift. They live on the rig for 3 to 6 months, the people that work those. And then they will come home for 3 to 6 months and they'll go back. And that's their job. That's their schedule. Just like, mom or dad might go to work for 8 hours and come home. Theirs is 3 to 6 months off and then back on. Yeah.
How many miles does national waters extend before it hits international waters?
20.
So some offshore rigs are probably in international waters.
Oh, for sure.
Therefore, not in the US.
Not technically, but you may still own it in a way. There's all kinds of weird laws about that. Drew?
Money, lots of money to get paid for that.
Oh yeah, there's huge money in the oil industry. Shoot, people have fought wars over it, big old deal. All right, so this is public lands, and I'm gonna see if this works. If it doesn't work, I'm gonna stick it over in YouTube, because remember, we had weirdness last week. Okay,
The federal land ownership, but I'm sure most of you have seen this chart with.
okay, that's fun. I don't know what does that. Hold on, I'm gonna do this again. We're gonna put it in YouTube because apparently it doesn't want to play. I don't know why. I thought I had it open, but I didn't. I opened the other one though. This is in the way. So when we talk about public lands, these are lands that are owned by, who owns them? Do you know?
The government?
Yep, which is technically who? Yeah, Alex.
Believe it's federal level.
But who is the government? And we're talking about who owns things technically, Bailey? It's the public, yeah, meaning the people who are paying the taxes own the stuff. Yeah, we're gonna get a commercial because we can't watch the video without it. Okay.
This. The federal land owners, I'm sure most of you have seen this chart with. Did you guys that? He's referring to this. It's a map of all the
Oh,
federally owned
sorry.
or public lands in the US. Public land for them in the news a lot lately. Tremendously positive things are going to happen on that incredible land. In short, public lands are the lands that are owned by the federal government, which is to say, they belong to all of us. But even about the headlines, we rarely talk about what actually makes us the public land. So what exactly are we talking about when we talk about public lands? Well, first off, we're talking about a lot, 640 million acres, which means that about 48% of the US is made up of public lands. As you can see, these lands are highly concentrated in the West. These are Latin American states, and then the rest of 46 billions. Alaska alone is 61.3% public land. And these are mostly massive and amazing. The Congressional Research Service says that total federal land in the United States is not definitely known. Yet that's largely because there's no single entity that controls them all. Instead, public lands are managed by a number of different agencies for different purposes. To illustrate that, let's look specifically at these 11 Western states, and let's break it down by agency so that this map is more like this. First, let's exclude the Bureau of Indian Affairs. Most of these lands are held in trusts on behalf of the indigenous tribes and are not technically owned by the federal government. Second, the Department of Defense lands. These are almost all military bases that serve a very specific purpose. What we're left with is 4 agencies that manage the bulk of America's public lands. The National Park Service is the smallest, with nearly 80 million acres. The NPS works to very strictly conserve the lands they manage, and their charge includes all the big names, like Yellowstone, Yosemite, Glacier, and Grand Canyon National Parks. Next is the Fish and Wildlife Service, with nearly 90 million acres, much of it in small plots, with the #1 goal to conserve plants and animals. After that is the Forest Service, with over 190 million acres, most of which are in the form of national forests. Fun fact, you can camp nearly anywhere in a national forest. It's called dispersed camping. Look it up. And that gets us to the big one, the Bureau of Land Management, with nearly 250 million acres. And this tends to be the controversial stuff. The Bureau of Land Management has to balance multiple uses of the land it manages, including recreation, grazing, timber, watershed, wildlife and fish habitat, and conservation. And it's the balance of these uses that causes most of the headlines. So, the next time you see a story related to public lands, remember this. Those 640 million acres that the federal government owns, they're not being held from you. They're being held for you. Those lands are owned by all of us, and they're there for all of us.
So we technically own it, but we don't technically have control over all of it. Oh, yeah, he'll do that. He's quite good at it. He usually wins. Yeah, he's a little insane. So we have, anybody ever heard the term the alphabet agencies? Anybody ever heard that one? Okay, so our alphabet agencies are FBI, CIA, Forest, yeah, all of these, all of these organizations that are federal organizations that all have good old abbreviations for their names. And these are the kind of agencies that end up owning, whoop, I'm sure I missed a page. maybe I didn't. They'd end up owning these lands. So stop it. You're not playing that again. Oh my gosh, I've had nothing but technical error for the last 2 weeks. That is obnoxious. Liz. I know I had a. Oh, okay. Sorry, here you go. So keep that in mind as we move on to talk about this next bit here. So what kind of resources do we get from our crust? Well, that's where most of them are going to be coming from. Yeah.
Alphabet soup.
Gonna be things like, that's where almost all metal comes from.
Mm-hmm.
That's gonna be where a lot of minerals come from, things like fertilizers.
Yeah.
batteries.
Pretty much everything is going to be coming. That's where all of our natural even trees and stuff grow out of it, right? So our land resources. So what do we call these areas of land and water that are owned collectively by citizens, Bailey? Yeah, public lands. All right, or publicly managed lands, either way. Okay, now, this is what I mean by alphabet agencies, and this is why we have alphabet soup. There's a bunch of them. What are the 3 biggest ones? Piper?
Yellowstone?
Well, that's a specific park.
Oh.
Agencies.
Then.
Do you know? Yusuf,
Wildlife.
No, national parks.
national parks is an answer. What's your answer?
National Forest.
National forests,
Department of Interior Land Management, I believe is one of them, and another is Fish and Wildlife.
fish and wildlife, Bailey,
Wildlife refuge.
wildlife refuge. Okay, so let's look at some of these. These are our 3 big ones. Okay, National Park Service, Bureau of Land Management, Fish and Wildlife Service. And yes, Drew, will you please go open the gate for your dog? I think he wants to go out the gate. Thank you. So yeah, these are what we mean by alphabet agencies. These are NPS, BLM. This was BLM before BLM was like in everybody's household name. And then FWS. And then if you look here, you've got these are what these agencies here maintain all of these. So amongst these 3 are your forests, your parks, your wildlife refuges, your national conservation areas, monuments, wildlife areas, historic sites, national memorials, battlefields, recreation areas, wild and historic rivers, national seashores, national lake shores, national trails. There's a lot. Anybody been to a national forest? Probably have driven through them if you live around here. Yeah, well, how about you? Stone Mountain, I don't think it's a national park service. I think it's state. How about you, Drew? Were you gonna say something?
I've been to one, I don't remember.
Yeah, so like driving to and from Knoxville, we drove through national forest for quite some distance. It's pretty common around here. There's national forests up in our mountains and to our west as well. So if you've driven any of that, you may have driven right through it. Yeah.
Yeah, when we're going from Ohio to Georgia, we go through many of them.
Yeah, there's a lot of them. And you've probably all seen national wildlife refuges, right? Especially along seashores and places like that, right? How about national memorials and battlefields and monuments? What are examples of these? Probably, that I believe that the MLK site is a national park, even though it's really a small one and it's urban.
I'm not sure if this counts, but there's some sort of small Civil War memorial
Mm-hmm.
at the Atlanta Zoo.
Yeah.
Yeah.
that's a tiny one.
Yeah, what were you gonna say? Annie in DC, yeah, the Washington Monument, the Jefferson Monument, these are all run by these people. Okay, absolutely. And Battlefield, Kennesaw, I believe that's a national battlefield, right? You can go to the Kennesaw Battlefield and visit that. And if you drive along through the mountains through national forests, very often you'll find yourself on along a national trail, and you can see the stops along the way. One thing you might find, especially where national parks are concerned, if you go to, like, say you stop, you're driving through a national forest and you're driving along through the mountains or whatever, and there's an overlook, a lot of those will have this little sign. You've probably seen this sign, right? Everybody's seen this. A lot of them were built either during or just after a particular presidential term. Do we know who was responsible for a lot of these national parks? Do you know?
I'm gonna guess FDR.
You were gonna guess?
Roosevelt.
Which one?
Teddy Roosevelt.
FDR's, right? Yep. So he had a big push, right? At the end of his, well, not the end of his, during his term, he had a big push for getting everybody jobs. And a lot of that getting everybody jobs was giving them government jobs to build parks and things. So you may notice some of these bathrooms in particular have architecture reflective of the 1930s or even into the 40s. And it's kind of interesting because a lot of them still look like they're real. The architecture is very simple and cost effective. So it's an interesting thing to see. All right, so what percent of the US is public land supported by taxpayers, managed by federal, state, or local governments? Chloe? 28. She's so 40 if you include all of it. 28 for the big chunk.
Guessing like this.
It's we just clicked it. So we're good. And this is what they are. So you got Indian Affairs, Land Management, Reclamation, Department of Defense, Fish and Wildlife, Forestry, Park, Tennessee Valley Authority, which is a very specific one, and other agencies. If you look at the Tennessee Valley Authority, it's only going to be like kind of in here. And that's responsible in particular for some of the watershed that comes through this area. All right, so public lands, we've got a fun little guessing game here. All right, so this is the rank of the state by percent federal land. The abbreviation for the state, the percent federal and the percent private. So this is a fun game. So nearly what percent of the US is public land? Oops, that was supposed to click that one first. Bummer, that was a fun one. 95.8% of Alaska is owned by you. Yikes, collectively, all of you. That's a lot,
Give me that power.
right? That's an awful lot. Only 4.2% of Alaska is private. So if you look down here, you'll see that most private here is Rhode Island. Why, when we look at that map, do you think we see most of the public land on the West Coast? What's the reason for that? Somebody who hasn't given me an answer yet. Why do you, well, hang on, Parker, why do you think that is? Why do you think there's so much more public land? This is a think question. Why do you think there's so much more public land in the western part of the US versus the eastern part?
Less government.
Less government. What do you think, Lily? Less people? That's a very good point. Mila, how about you? What do you think?
I'm not gonna say more government.
More government.
I could like the double.
How about you, Caitlin? Why do you think? Don't know? You don't have a thought? Lily, you have another thought? Less politics? All right, Yusuf, what do you think?
More forest and more natural habitats and more space.
All right. How about you, Liam?
You say like more space.
More space? All right, James, what were you gonna say? You had your hand up a minute ago.
I was gonna say that there's a lot less population.
Less population is definitely a big reason. Alex?
Part of it's gonna be, there's a lot of national parks there, like Grand Canyon, Yellowstone,
Right.
because of interesting natural things there, so that's part of it.
Mhm.
Another is probably because it came later and people went to explore it, that led to more of it ending up being.
Yeah. Bailey, did you have anything to add to that?
I was gonna say.
Yeah. So, yeah, if you think about how our country was settled, it was settled from the east to the west by Europeans, right? So when Europeans came over and settled the country, it was east to west primarily. And a lot of the west that is part of the US was part of, does anybody know how we mapped that out and figured out where it was? Do you know, Bailey?
God, no.
Nope, can't remember. You know?
Lewis and Clark.
Lewis and Clark. There you go. What president did that? Caitlin.
Jefferson.
Jefferson. All right. So Jefferson sends out Lewis and Clark and they go map out the western part of this country, basically. And then he paid basically nothing for it, the chunks that he bought from everybody else, France and whatnot. Yeah. So
Spain.
so you're talking about an area that's been settled much later. And because of that, there weren't as many people to stake their claim on a particular spot. Like if you go to Massachusetts or someplace, especially along the coastline, like every little thing is owned by people, right? Because they've been there forever. You know, people have been there 300 years or whatever. All right, so Oregon. I will take two guesses. Two guesses on Oregon, percent federal, percent private. All right, Piper, what's your guess?
Somewhere like in 60s.
60%
So federal.
federal, 40-ish private. Okay, Caitlin, what's your guess?
70, 30.
70-30. All right, let's see what we get. We got 60.4. Oh, man, Piper was almost spot on. All right, now New Mexico. New Mexico. All right, let's see. Yusuf.
New Mexico.
Oh, he's looking it up. Okay, what is it? Oh, he's looking at the picture. All right, What do we think?
43.9.
43.9, and then whatever the rest is. Liam.
Like 45. Like 45.
45-ish. All right, let's see. So we got about 47.4 to 52.6. So pretty, you got close there, Liam. All right, Hawaii. Bailey, what do you think?
20%, like 80% on.
2080? Pretty darn close. All right, James, what do you think for Virginia? I'll take 2 for this one. Virginia? What do you think?
I think 17. 80. 1780.
1788, you're going right on the dot. All right, Alex.
17.193.
Okay. All right, 17.193. We got 17.1. Oh, you're so close there to 82. All righty. And a lot of that federal land in Virginia is going to be forest in the western part of the state. And in the eastern part of the state, you're going to have a lot of, and in the middle, you're going to have a lot of like parks, monuments, historical sites.
Georgia has less public, oh wait, never mind, wait.
Or number 33.
We're number 33. Yep. So how about Missouri? Who wants to give a guess on Missouri? All right, Milo, what do you think?
11.5 and.
The rest.
And then the rest. Okay.
88.5.
La, 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 la. Okay, Yusuf. Whoa. It's got to be in this little range here. So 11.2. So we're good. All right. Oklahoma. What do you think a lot of that federal land in Missouri is going to be?
Water.
So big. You're definitely going to find your Bureau of Indian Affairs in Oklahoma and Missouri, right? Think about it. You don't find as much Indian reserved land here in Georgia as you're going to find out there, right? Because that's where the reservations are, giant chunks of land that we've said, okay, you guys get to keep this. Oklahoma, Liam.
Like 4.9.
4.9, okay, and Lily.
Maybe like. 4.7.
Okay, let's see.
7%.
4.6. You're real close. Nebraska, Drew, what do you think? Less than 2.8, right?
Less than 2.6. Say 1 on that.
1 on the dot. Okay, Piper.
Like 1.9.
Okay. Let's see. 2.8. So, okay, it's this exactly the same as Iowa. All right, how about Kansas? Parker.
1.9.
1.9. Lily.
1.4.
1.9, 1.4.
0.
Wow, we are good. Look at how good we are. All right, and our last one here, Rhode Island. All right, Liam? 0. Okay, Caitlin?
1.
1. Okay, Rhode Island is 1.5. Why do you think Rhode Island is so much less than the others?
Yes.
It's right. It's okay. It's could stroll through it today. There it is. So this ends up with our close to 40%, right? So nearly 40% of the US is public land supported by taxpayers, which is, like I said, you don't get control over it, but technically you collectively own it. Interestingly, the Bureau of Indian Affairs, they like it said in the video, they don't own that land, but they hold it in trust for the indigenous people who do live on the land. And they have, Alex quit, they do have different laws there. Not everything applies the same way. For example, this is an interesting thing, but okay, say somebody is murdered in Georgia. Who handles that case legally? Who?
The judge.
Well, no, like somebody gets murdered in Forsyth County, who handles that case? Sometimes it's the state, but usually it's the county. It's your local jurisdiction,
Like,
right? Who do you suppose does that on the Indian reservations, Bailey? Which is, what's the National Law Enforcement Agency? FBI. Yeah, they come right on in and that's what they do. Yep. So if something bad happens on an Indian reservation that requires legal and it goes beyond like basic stuff that their own force manages, it's FBI. Mhm. Why? Because it's federal. So it's federal and the federal law enforcement agency is the FBI. All right, so let's see, what do we have next? So now we're going to talk about soil as a resource. We have topsoil loss and erosion, and we know what that is. We know how that happens. So what is caused by topsoil loss in arid areas, Liam? I love that word, desertification, desertification. Yes, there you go. So it looks like that, and it's terrible, and it's not good. We know all about erosion because we've been through this. All right, now we have this type of quote unquote topsoil, and it's the stuff that is sand, gravel, and crushed rock. What do we call that, Piper? Oop, she had it. She's turning. Aggregate. Aggregate. That's a good one. All right, and Chloe, what is this stuff that's solid limestone, marble, granite? Do you know? Bedrock. Okay, so we've got all these things going on, right?
The strongest block in Minecraft.
The strongest block in Minecraft. All right. So your aggregates can look like this, right? What is mined in Forsyth County? Do we know what gets mined here?
Isn't it iron or quartz?
Not primarily. They may run into some. Do you know, James? Granite is mined in Forsyth County. It's mined in at least 2 places I can think of off the top of my head. Anybody know where one of them is? Alex?
There's one right near the hospital,
Yep.
and I believe one's off a highway.
Yeah.
And going to the federal thing with FBI, so theoretically, if someone were to die in a national park, it would be the FBI that got called in.
They do quite often. Yes, absolutely. Which is interesting. Mhm. There's actually there's a podcast in particular called Park Predators, and all it does is crimes in national parks. And you hear a lot about the FBI's involvement with stuff like that. So yes, one of them is absolutely right there on Ronald Reagan near the hospital. There's another big granite quarry over in Johns Creek near the Taco Bell. Do you know where that is? Where the Taco Bell in Johns Creek is? There's a little road there, like one side goes to the neighborhood Deer Lake and the other side just kind of disappears. There's a little Indian grocery store on the corner. Anyway, if you go down there, well, you can't go down there because that's a quarry.
If somebody were to die on an oil rig in international waters, what would
It probably belongs to whoever owns that rig, and then that person probably falls under a national jurisdiction of some kind. But that's an interesting question.
on the rig, it would be the FBI.
If the US owned it, but typically it's a company that owns it. All right, so what are substances that we mine for profit? We've done this one before too. Drew?
Diamonds.
No, what's that? That is true. What is, that is accurate, but what do we call as a general whole? You are right though, diamonds, huh? Yeah, that can be one of them, Ores, what we're looking for is, so ores are what we mine for profit, right? Okay, that's just the definition. But there are types of ores, and as Drew pointed out, diamonds, yeah, I would love to find a diamond deposit in my yard. I would tear up the yard for that in a heartbeat. So minerals crystallize and settle to the bottom of a magma pool, and that's how you get things like iron, chromium, and platinum ore. Some ores form around what kind of vent? Oh my gracious, Milo. Yeah, these hydrothermal vents, which as we know are underwater. So you're talking about in particular ores that form around vents when they were underwater, but now they're no longer underwater and they can be mined from the land. And those are things like copper and gold. All right, so Bailey, what are ores that form from chemical what?
They mix, I forgot the word.
Mhm.
They mix together.
Reaction.
Yeah.
Oh, not-
No, that wasn't the one I was looking for. That's good. Do you know, Yusuf, what I'm looking for? Precipitation. Okay, again, this is another one. Precipitation is going to involve fluid, right? So very often when you're dealing with, y'all are weird over there. When you're dealing with precipitated ores, like I think way back when we talked about precipitation, there was some pictures of certain or like iron precipitate on a seafloor. You could see just like little clumps of it everywhere. So that can happen. And then once again, when that piece of land is uplifted and it's no longer underwater, then you can start mining it. So what form when denser substances are sorted in sediment deposits like gold, platinum, diamond, gemstones, tin, titanium oxide, Yusuf?
Placer deposit.
Yeah, those are called placer deposits. Okay. And then this last one here. What do I want for this? Tailings or what is left behind? What do we want for this one? Do you know, Bailey? No, I wasn't sure if that was a hand or not. Piper, you're guessing? You want to guess? Alex?
Waste products.
Waste products?
Waste management.
We're looking for just general effects, but yes, these are the waste products sometimes. The tailings are actually, they're not really the waste, but they're what gets left behind. They're the deposits. You good back there, Parker and Milo and everybody? These are what, this is what gets left behind when they do mining. They don't get every little bit. There's always something left, and this is what's left behind. All right, now, air. We got air. So, what's our origin of oxygen? We should know this. Bailey.
Those little.
These little guys? Yep. She's going. What are they called? She's thinking.
Creatures.
Yeah, that's right. That's right. James, what's another word for him? Algae. Yeah. What's another word for him? Yeah. Phytoplankton. Yeah. These guys.
Or cyanobacteria.
And or cyanobacteria. Yeah. Kind of all the same grouping. All right. Now I will tell you this. My 8th grade biology teacher was not the greatest biology teacher. She was like way too chill. Like did the bare minimum. But you see these little guys right here with the tails? Somebody tell me what that is. What's the word? Liam.
Dinoflagellates.
That is a dinoflagellate. She called them dincoflagellates for the whole school year. It was all I could do not to, I mean, I actually said, is it dinoflagellate? So these dincoflagellates, and I'm like, oh no.
It's not even, so they got, okay.
No, so God bless Mrs. Faison. She was also so non-observant that she didn't see the little fetal pig heads that left our classroom and ended up in our English teacher's coffee cup. So yeah, failure to properly manage, I should say, would be part of her problems. That particular, no, this particular English teacher, she was very nice. She was very, very nice. Actually, Jason was in the class with me, but she was older and very opinionated and a little judgy. Like we had a couple wrestlers in our class and she's like, I don't know why anyone would want to get in little skimpy clothes and roll around sweaty with another male on a mat. So of course, you know, the questions that followed that, well, would you prefer it be a male? And you know, all these questions, right? And so, but anything people could do to her, they did to her. I felt bad for her. Except the one time we did something funny, which is everybody set their watch to go off about 5 seconds after the next guy's watch. So now you have phones, but we used to have little alarms. So they all just would go off and she'd go and take it. And then somebody else's would go off. She had a whole drawer full of watches. She even took mine. It didn't make a sound. But anyway, there's not dincoflagellates. These are dinoflagellates. Yes, they are. I don't know. Why is it still doing that? Stop that. Okay. Hello. Oh. Why are you being stupid? No, don't be dumb. There we go. All right, so let me make sure I didn't miss anything because it was stupid. There we go. So we know that our iron is coming from our dincoflagellates, and the law of conservation of mass is going to say, what about it now? We've got mass and matter. It's the same. Mass and matter are practically identically. Just switch out the word. Bailey?
They can't be created nor destroyed, only.
Right, that's the exact same thing, mass and matter, right? One says mass, one says matter, it's exactly the same. So we got oxygen in the air, right? So for example, here, if you burn a fire and the logs disappear, that matter that mass, that matter did not disappear. It turned into carbon dioxide, water vapor, and ash,
It's in the
right?
air.
It's in the air, or it's what's left in the bottom of your fire pit.
Written in law.
Another good way to think of your law of conservation of mass and matter. This is a good one. 2 graham crackers plus 1 marshmallow plus 1 chocolate equals 1 s'more. Yeah, but all those things are still there. You may have a s'more now, but all the parts that made the s'more are still there, right? All right. So the law of conservation of matter, which we said, mass of an object or collection of objects never changes over time, no matter how the constituent parts change or rearrange. And the law requires that during any nuclear reaction, radioactive decay or chemical reaction in an isolated system, what's an isolated system? Somebody besides these 3. Somebody tell me what an isolated system is. Cole, what's an isolated system? Thanks so much. He's graduating in like 2 months. All right.
Good answer.
What's an isolated system, Drew?
That's a system that is not affected by gas.
Yeah, okay, it's sealed off from the rest of the environment. So requires that during any nuclear reaction, radioactive decay, or chemical reaction in an isolated system, the total mass of the reactants or starting materials is equal to the total mass of the products. We're back to chemistry, right? Reactants are what you start with, products are what you end with. So, whoop, that doesn't help you because there's nothing there. This is our carbon cycle. Now we have all kinds of cycles within Earth's, normal day-to-day life, right? We've got carbon cycles, nitrogen cycles, we've got water cycles. You guys know that one, right? There's a rock cycle, right? So our carbon cycle, carbon can be part of seawater, the atmosphere, rocks, coal, soil, and of course, all living things, right? Because we are, what kind of organisms? We are, starts with an O, James, organic, so therefore we contain carbon. All right, so we're all part of the carbon cycle. So it's nature's way of reusing carbon atoms, which travel from the atmosphere into organisms in the earth, and then back to the atmosphere and over and over and over again. Carbon is stored, most carbon is stored in rocks and in sediments, while the rest is stored in the ocean, atmosphere, and in living organisms. So when I die, okay, if they were to bury me, which is not what I asked for, but if they were to bury me and plunk me down in the ground, all of the carbon and iron and nitrogen, what are the big things in living things? Does anybody remember what they are? The big elements that are in living things? Drew, do you remember?
Wait, how many of them are there?
6.
So wait, is it nitrogen,
That's-
carbon? What carbon is the big piece? Nitrogen, carbon, hydrogen,
Mm-hmm,
I think oxygen,
mm-hmm.
and
Anybody know the other 3? Huh? What now?
iron maybe?
Nope, not iron. Do you know the other 3, James?
Phosphorus.
Mhm.
I know another one.
I don't know.
What's another one, Alex?
Sulfur.
Sulfur, and there was one more.
Sodium?
Do you know?
Calcium.
Nope.
Sodium.
Do you know?
Potassium.
Nope, but the letter's close. Do you remember?
Sodium chloride.
Nope.
Letter as in,
So CHNOPS, carbon, say it with me, hydrogen, oxygen, nitrogen, phosphorus, sulfur. That's what we're looking for. Okay, so if they plunk my butt down in the ground, all my schnapps, CHNOPS, are gonna back into the soil, back into whatever. Some grass might grow and a deer might eat the grass. Well, the grass is going to contain hydrocarbons to a degree because it's a living thing, and it could just very well be eating what was once me. That's how it works. Round and round and round. Yep, round and round. Whatever you put in your car and you burn, dead swamp material, right? Round and round and round.
I can provide bodies for this, for
You know that you can be cremated and then put in like a root ball of a tree that they can plant, and basically the tree grows from you. That's a thing now too. Yeah.
Can I cut down one of those trees and use it for firewood?
No.
That would just put you back into the ground and get into the air. All right, so what cycle is this then? Bailey,
Life cycle.
Oh, no,
wait a minute, she's looking, she can't see it. Can I make it bigger? How about that? Does this help?
Nitrification.
Yeah, no, never mind.
Okay, what were you gonna say, Alex?
Nitrogen.
This is our nitrogen cycle. Okay. So our why are we doing this again? Why are we doing this again? Why is this thing stupid? Okay, our nitrogen cycle. All right, if I can make it move now. Oh, fun. That's fun. Go away. Stop doing. Okay. Okay, well, it did it all at once. There you go. So your nitrogen cycle. So you have nitrogen fixing bacteria, and they're going to convert nitrogen to a form that can be used by plants. And then you get this nitrogen cycle that goes round and round and round. And nitrogen moves through living and non-living things, the atmosphere, soil, water, plants, animals, bacteria. In order to move through different parts of the cycle, it has to change forms. And nitrogen cycle is very, very specific. We talk about it a little bit in biology. If you get into ecology or anything in that vein, this will be something that will be really important for you to know and understand. But without these particular bacteria doing what they do in the soil, we could not have our nitrogen cycle around. And we need to, because there are a finite number of nitrogen atoms, essentially. Some of them are connected to other things. Some of them are just connected to each other and floating around.
Nitrogen, there's only a small percentage of the nitrogen on the planet is actually useful. The rest of it's locked up in the atmosphere.
Yeah.
Because N2 is triple bonded, which makes it very, very hard to break.
And most of your air, your atmospheric air, there's more nitrogen in it than any other element.
Yeah, that's nitrogen. But
So what is a substance that enters Earth's geochemical cycles that can harm living things, Yusuf? That's a pollutant. Okay. Now, when we get to these films, all right, you're going to see people describe pollutant a little differently. Like some people are going to say that CO2 is a pollutant, and some people are going to disagree that it's not. That's part of the normal process. So keep that in mind, that it is technically something that harms living things. Sometimes it directly harms living things. Sometimes it harms the ecosystem. Does anybody remember what you call a living thing that alerts us to a problem in the ecosystem, James? An indicator species, spot on. Give me an example. Frog. Yep. Why is a frog a good example of an indicator species, James?
Because if it's living in a freshwater pond,
Mm-hmm.
then that usually means the water is clean because they absorb.
Right. Their skin is very permeable, right? They can breathe to a degree through their skin. They can absorb. This is why you don't ever like have dirty hands or chemically hands and pick up a frog. We were walking through Home Depot one day and the little green tree frog was hopping around in there. And I felt terrible for it because it was covered in Home Depot dust, just covered. It was completely gray, fuzzy looking. So we took it home and took it out on the back deck and very gently washed all of its skin off because it was gross. And we took him down to the river, which is not where he came from. I don't know what happened to him, but goodness knows what absorbed through his skin on the floor of Home Depot, like of all places to be. I also found a frog in Target once too. It jumped on my foot. I wasn't as concerned about that frog as the one in Home Depot. All right, so volcanoes. These put out ash, sulfur dioxide. What's going on here?
That's a
Alex,
fire.
that is a wildfire. So wildfires are going to put smoke, particulate, chemicals into the air.
Seeds.
And then what's this picture going to be about? All right, Liam.
Radon.
Radon. Okay, radon is a carcinogen. What is a carcinogen? Yeah.
It is any substance or like that causes cancer
Mhm.
or increases your likelihood of cancer.
That's right. A carcinogen is a cancer-causing substance or likely increases your chance, okay? So radon is undergoing a form of radioactive decay and it's present in rocks inside the earth. So the concern for radon is for people who have basements. So if you have a basement in your home and say you're trying to sell your home, you may have to have a radon inspection. We did that when we sold our last house. They wanted a radon inspection. Go in there, make sure that it's not radioactive in here because sometimes it is, and that's not a good situation, obviously. So changing of pollutants in the atmosphere. We've got these ways that pollutants change and move around. So we have the movement of pollutants in the atmosphere caused by a time averaged wind flow. What was this one called, Bailey?
Transport.
Okay, yep. Transport, that's what we're looking for. So we got transport, and this dispersion results from local turbulence in the atmosphere. So it says that is motions last less than the time used to average the transport. Okay, so what occurs owing to the mixing of air, Yusuf? Dilution. Okay, that makes perfect sense, right? If you mix sugar in with water, you're making a diluted sugar solution unless you start adding a whole lot more. Same thing happens with air. You start mixing it together, it gets diluted, the particulate does. So it's separation or accumulation of pollutants that occur on a basis of physical characteristics of the pollutant. So for example, some are going to deposit, some are going to precipitate. And if it's a particularly heavy, a lot of mass for that particle, it's more likely to come back down or come to the bottom of the environment as opposed to lighter molecules, which are going to make their way up. All right, so what do we have? This should say 3. I caught it before you. Chemical reactions occur, breaking down the original pollutant and converting it into new. What is it, Bailey?
Transformation, and then I see that, but then number 4 is 3.
Yeah, that because of the 2. Yeah. Once you put in one number, it's going to automatically count for you. For some reason, it did that. Yep. So what's this last one? Removal mechanisms include absorption by vegetation, soil, stone, and water bodies, precipitation, scavenging, and chemical reactions within the atmosphere. Bailey, what's the last one there? Yeah, that's how we get, this is how we're getting it out. All right. So be aware of these systems. Let's talk about water for our last bit.
A comma missing
Oh, you think?
in between precipitation and scavenging.
I think you're right. I'll check that. Yep.
That.
Okay, water resources. All right. So our properties of water. You can have it liquid, and when it's liquid, we have hydrogen bonds. What's particular about hydrogen bonds that mean they have a positive and a negative end? What do we call molecules with a positive and negative end? James? Yeah, they're polar. Okay, we're bipolar because they have both a positive and a negative end. All right, so this is important because it allows, these hydrogen bonds allow for water to bond firmly enough that you get things like surface tension, for example, but not so strong that you can't easily pour water from one cup to another and, divide it into bits.
Same reason that you have capillary action.
Yes, same reason you have capillary action. Anybody remember what capillary action is? James? Like a small tube. You ever go to the doctor and they prick your finger and the little blood drop hits and they put that little tiny glass tube on it and your blood goes up? That's due to the hydrogen bonds. That's capillary action. So thermal energy, how about water and thermal energy? Thermal energy storage capacity. Does it store large amounts or small amounts of thermal energy? Milo. Okay, so stores large amounts of thermal energy. Now this, I want you to remember, because again, when we get back into our climate change documentaries, don't you know ocean temperature is going to come back. What was the point about ocean temperature in the last round of documentaries? Who remembers? Drew.
Warm waters, warm waters that absorb CO2.
The colder the water,
CO2.
the more gas it can dissolve. Correct.
Uh-huh. But if the climate gets warmer, the oceans become warmer and they can absorb it.
If the climate gets warmer, the oceans get warmer and they can absorb less CO2. And the point of, the point of global warming swindle was that the environment got warmer because of what, Drew?
Because sunspots.
So yeah, sunspots, solar flares, that cause global heating, which cause the ocean to get warm, which makes it harder to dissolve gases, which means there's which means there's more CO2 in the atmosphere. So their point is that the point of Al Gore's movie was that we're putting carbon dioxide into the air, and that is causing everything to warm up. And global warming swindle said, no, sunspots are warming the earth, and therefore the oceans can't absorb as much carbon dioxide. And now we have, warmer earth, and it's the other way around. So water is a solvent. What kind of a solvent? What do we call water as with regards to being a solvent, Alex?
Universal.
It's universal solvent. Yeah, okay.
Well, it can't dissolve non-polar.
Yes, okay. And this is super important to remember, especially ecologically. Solid water freezes, expands, and what happens to its density? Drew.
So, all my other things, because I do it,
Add more
when
queens.
it's cold, it starts to shrink, when it starts to freeze, it expands. Okay, so water is going to expand.
When it gets cold. Yeah, when it gets cold. That's why your ice cubes float, because it expands and they are less dense. So it's less dense that we're looking for here. All right. So that's important because that means your ponds and your other bodies of water freeze from the top down. If it all froze at one time and the less dense ice didn't go to the top, then all your organisms that live underneath would freeze.
And the reason that it does this is because after a certain point, the water will expand and into regular pattern. Like crystalline.
Yep.
Instead of normal.
It locks into a crystal pattern and that causes it to spread out, causes the molecules to spread out.
Which somewhat creates air in it and definitely decreases density.
All right, so water distribution on Earth, location of fresh water resources. Now, you can't go drinking as a general rule, seawater, right? Salt water is not safe to be drinking because you'll put too much salt in your body and your body will do all kinds of fun things with extra sodium. That's the least of your concerns. So
I'm thirsty.
your fresh water is a resource that's not evenly distributed. Where are some places we find fresh water? Alex?
Rivers. lakes,
Rivers, lakes,
ponds.
Yusuf? Liam, eyes, Bailey, Rain, and Drew, one more. That wasn't what I was asking, but okay, all right. In my glass. Okay, so yeah, we find fresh water in, here are some of the places. Glaciers, lakes, reservoirs, ponds, rivers, streams, wetlands, and groundwater, most of which is found where?
In the ground.
Glaciers have most of our accessible fresh water, but we don't go after it, right? Because that could be all kinds of issues. Yeah. So freshwater habitats are less than 1% of the world's surface area, yet they house what percentage of all known animals and fish in particular? All right, Bailey. Yeah, well, let's see. About 10% of all known animals, and what percentage of all known fish? Well, that's going to be a good number, 40%. Because, yeah, the other 60% are not in the freshwater, they're in the,
Salt.
yeah, so what kind of life form are they then? We call them marine, not aquatic, but marine. Very good. Okay, now, here's your little thing. The Earth is 97.5 salt water. And then you've got your fresh water, and here's where it is as far as ice, groundwater, surface water.
Surface water is 0.4% of 2.5%.
Not a whole lot. So uses of freshwater resources. In the US, what percent comes from aquifers? Do we know? Anybody want to guess? Drew, take a guess.
17%.
17%. And remember, an aquifer is like a little lake underground. 23 is going to come from aquifers. And you must not pump at rates that are higher than the, what do we call it, Bailey? Replenishing. Yep. What's the word for it? Do we know, Piper? Close. Do you know? Recharge. Yes. Okay. Not more than the recharge. Okay. Worldwide consumption. Mostly it's going to be for irrigation. Most of our water, fresh water, goes to our crops, not to us, not to the local swimming pool, to our crops. And then power plant and factory cooling. This is exactly what Drew referenced when he was talking about nuclear power plants and all the vapor coming out of them. That's just water. They're usually on a river or a body of water. If you've ever seen the ones on the coastal South Carolina, not far from Savannah, there's a bunch of them there. It's kind of cool to see. All right, so managing fresh water. So dams and reservoirs control 25 to 50% of the runoff on every continent. Transporting surface water, we use things like aqueducts that eventually evolved into pipelines. The Romans made aqueducts way back in the day, right? We're talking old technology here, but now we have pipelines that are underground and whatnot. We got wells that we can use to tap underground water. Now, desalination, this is a big one. This right here is Sorek. Sorek was built in 2013. Israel is the only country that has managed to desalinate seawater for use as freshwater on any kind of a grand scale, and they've managed to make it work. They produce 627,000 cubic meters of water a day. And that provides evidence that, you know, you can get large desalination facilities working. But this is a huge government funded project that we have in Israel. So they have all the resources that the government has. But there are island nations, you know, that you'd think, oh, this would be smart for them to learn how to make the seawater palatable or potable. But nope, Israel's the only place that's managed to do it. So it's kind of interesting. That's one thing they have going for themselves that's not necessarily the same as everybody else. Now we'll see if this goes. If it doesn't, I already have it open. Actually, you know what? Since I already have it open, I'm going to open the, I'm going to open it in YouTube because I know it'll play well. Did you have a question, Yusuf? No? Oh, I thought your hand was up. It's not. Sorry. I'm just pointing you out for no reason whatsoever. Okay. So how much land does it take to power the world? Interesting thought. Let's see.
Size of a kitchen table.
You think?
No matter how we make electricity, it takes up space. Electricity from coal requires mines and plants to burn it and convert the heat into electricity. Nuclear power takes uranium mines, facilities to refine the uranium, a reactor, and a place to store the spent fuel safely. Renewable energy needs wind turbines or solar panels. How much space depends on the power source. Say you wanted to power a 10-watt light bulb with fossil fuels like coal. Fossil fuels can produce up to 2,000 watts per square meter, so it would only take a credit card-sized chunk of land to power the light bulb. With nuclear power, you might only need an area about the size of the palms of your hands. With solar power, you need at least 0.3 square meters of land, twice the size of a cafeteria tray. Wind power would take roughly 7 square meters, about half the size of a parking space, to power the bulb. When you consider the space needed to power cities, countries, and the whole world, it adds up fast. Today, the world uses 3 trillion watts of electricity.
Yeah. Hello. What
And
happened?
you'll need at least
There you go.
about 1,200 square kilometers of space, roughly the area of Grand Bahama Island. With nuclear energy, you need almost 4 times as much space at a minimum, roughly 4,000 square kilometers, a little less than the area of Delaware. With solar, you need at least 95,000 square kilometers, approximately the area of South Korea. With wind power, you need 2 million, about the area of Mexico. For each power source, there's variability in how much power it can generate per square meter, but these numbers give us a general sense of the space needed. Of course, building energy infrastructure in a desert, a rainforest, a town,
Hello, why are you doing this?
and energy sources monopolize the space they occupy to very different extents. Take wind power. Wind turbines need to be spread out, sometimes half a kilometer apart, so that the turbulence from one turbine doesn't reduce the efficiency of the others. So much of the land needed to generate wind power is still available for other uses. But the baseline amount of space still matters, because cities and other densely populated areas have high electricity demands, and space near them is often limited. Our current power infrastructure works best when electricity is generated where and when it's needed, rather than being stored or sent across long distances. Still, space demands are only part of the equation. As of 2020, 2/3 of our electricity comes from fossil fuels. Every year, electricity generation is responsible for about 27% of the more than 50 billion tons of greenhouse gases we add to the atmosphere, accelerating climate change and all its harms. So although fossil fuels require the least space of our existing technologies, we can't continue to rely on them. Cost is another consideration. Nuclear plants don't emit greenhouse gases and don't require much space, but they're way more expensive to build than solar panels or wind turbines and have waste to deal with. Renewables have almost no marginal costs. Unlike with plants powered by fossil fuels, you don't need to keep purchasing fuel to generate electricity. But you do need lots of wind and sunlight, which are more available in some places than others. No single approach will be the best option to power the entire world while eliminating harmful greenhouse gas emissions. For some places, nuclear power might be the best option for replacing fossil fuels. Others, like the US, have the natural resources to get most or all of their electricity from renewables. And across the board, we should be working to make our power sources better, safer in the case of nuclear, and easier to store and transport in the case of renewables. Okay, so that's how much space we need to power the world, but exactly how much electricity?
I expected the child was about to punch that
Oh.
globe.
No, not yet, not really.
Like they're about to get exploded.
Or what?
Okay, so obviously, some things take up a lot of space. Now, this is one of the complaints when it comes to nuclear and, oops, wait, that's not this, wait, I opened the wrong one. When it comes to stuff like nuclear and nuclear takes up some space, coal takes up some space, oil takes up some space, but when you get into stuff like wind and solar, it takes up a lot of space, right? And we'll talk about that next week when we talk about energy resources in particular. So this leads us, this earth resources leads us into energy resources. Next week's lab, okay, it's the last hands-on lab of the quarter because we've got next week, we're going to talk about energy resources and we're going to do that lab. And then the following week, we're going to talk about human impact, but we will start our documentary lab. And then the last lesson of the quarter is all documentary lab, like I said. Next week's lab is about cleaning up oil spills. So there's potential to get messy. All right, you're going to need to be like aware of that before you come. We're going to try not to get olive oil all over the place because I don't want to have to call you and be like, okay, everybody's coming back to clean my house because this is crazy. Or I'll call the lady that cleans for me like once every 2 or 3 months and y'all can pay for her. So no, I'm just kidding. But for real, there will be potential to get greasy. So we'll have aprons and whatnot, but be aware if you have your favorite pair of suede shoes, I would not wear them next week, right? Suede shoes will get jacked up by oil. All right, so these are your answers. They will be, like always, available for you. Does anybody have any questions?
How flammable is suede?
I have never tried to burn suede. Never been a thing for me. All right, there we go.
Oh.